We have here Staphylococcus aureus on blood agar, which is gram-positive bacterium. It's easily provable. It's ivory color and beta hemolytic. Then we have Staphylococcus pyogenes on blood agar. We have cultivation at 37 degrees, gray-white colonies or transparent colonies, small colonies, and beta hemolysis. We have, what is this?
Put in order again, otherwise we're gonna get lost.
Streptococcus pneumoniae on blood agar, smooth colony, slimy appearance, central depression in colonies, greenish surrounding due to alpha hemolysis, and 5 to 10% carbon dioxide favors growth but is not obligatory.
Greenish color, I can see the greenish color here.
If you see from the back, it's a bit.
Yeah, no. Yeah, maybe from this. You can see here.
Then we have the optogene test for the distinguishing between Streptococcus pneumoniae and viridans. It is used to distinguish between group A and group B streptococci. Optogene disc is placed in the center of the Petri dish. Here we have 2. Streptococcus pneumoniae are inhibited in growth, so the test result is positive in here when there is a circle around it. The next is Bactizatrin test for Streptococcus pyogenes and Streptococcus agalacticae. Bactizatrin disc is placed in the middle and suppresses only Streptococcus pyogenes. So if there is a suppression of growth, it's positive for pyogenes. Now we have E. coli in Leven agar. It's gram-negative bacterium fermenter of glucose, lactose, and mannitol, selective and differential agar, selective for enteric bacteria, differential for lactose fermenters. Lactose fermenters appear in color, here in green. Non-lactose fermenters, no color, and E. coli. E. coli on desoxycholate agar is also selective and differential medium. Selective for gram-negative, differential for lactose fermenters. Lactose fermenters appear pink, such as E. coli here. Proteus. Proteus on simple agar, we find Hauch colonies, which is a diffuse growth. It's a clear agar, and there is no specific colony growth. Which is next?
Sì, passa il prossimo. Sì, no, dico cada verso.
Okay, this is Löwenstein-Jensen agar. It is a greenish color. It is for the distinguishing of tuberculosis. Culture time is very long, up to 3 weeks or longer. Dry and flower-like colonies. It's a slant agar, selective for Mycobacterium tuberculosis. Lipid-containing media. It's actually a glycerol egg agar. Where is the saburodextrose agar?
Because we were doing it in order. I don't know.
Yeah, this is order 2
here.
here. Saburose, dextrose.
Yeah, this one. This is the saborose.
But there are 2. One is positive.
This has got is glucose broth. This has got candida. This is plain one. So it depends which one you want. Plain saborode or candida saborode.
So don't know that much saborode agars. So this is positive for Candida albicans, and this is just there. Don't know. Sorry for that. Standard antibiogram by the methods of Bauer-Kirby. It is a Petri dish that checks for the antibiotic susceptibility of bacteria. Circles around the disc indicate well fermenting of antibiotics. Methods to determine the sensitivity of microorganisms to specific antimicrobial drugs. We find zone of inhibition, and we have a minimum inhibitory concentration. The pure culture from the patient has to be isolated first. That's a Kligler for E. coli. It is fermenter of glucose and lactose. It's yellow. It has gas and yellow.
Negative reactions all day.
And we have Salmonella species, which is first of all distinguished by the ring, the black H2S. It was positive for glucose fermentation, but negative for lactose. This is why the upper part is purple or pink, however you'd like. How was Shigella, guys?
I think it's lactose negative, but glucose fermenting. So non-lactose fermenting, but glucose fermenting.
Okay, so Shigella. And then we have Proteus species, which are very distinguished between, because it has a lot of H2S here. Proteus species.
Negative and glucose negative.
Actually don't know, sorry.
That's right.
Which one now? This is Candida albicans, right? Yep, Candida albicans on the chromogenic agar. This was Proteus on the Müller-Hinton agar or simple agar.
Can you repeat because it was
What did I say? Oh, Pseudomonas, sorry. Pseudomonas aeruginosa on the Müller-Hinton agar. It's greenish coloration. You will also find greenish coloration in wounds of patients. So if they tell you there is a green wound, it's green also here. We did that. We did a glucose broth. In this case, it's positive for anthrax because of the cotton ball here. Hemocultures. So we have hemocultures for aerobes and anaerobes. We have a ratio of 1:5 blood and the liquid inside. We take venous blood for bacteria, arterial blood for fungi. We have a slight different volume for kids.
Sure.
This is for bacteria.
Which one is for bacteria?
Actually,
They both are.
they're
One's
both
for
are.
aerobic, one's for anaerobic.
Oh, okay.
We have, in general, a pouch which is for micro and aerophile bacteria. That means we need a 5 to 10% carbon dioxide in the atmosphere. This is especially for Neisseria gonorrhoeae, but also for Neisseria meningitis. We have a little bag in there which we break, and it absorbs the oxygen in order to provide. Then we have the same thing, but for strict anaerobes. This, in this case, is Clostridium perfringens. We actually have a blue pouch. This chemical provides to suck in all the oxygen. Haemophilus influenza on chocolate agar is just brown. Then we have the CUM test, which is for Streptococcus pyogenes and for
It's agalacticae.
agalacticae. It is positive for pyogenes if there is an error forming. In this case, it's actually not.
None of them.
There is another CAM test, but look for the error. If it's an error, it's positive. If not, then not.
So you wouldn't consider this an error?
No.